Hola, bueno, muy buenos días, bienvenidos, bienvenidas a todos a un nuevo episodio de Polémica en Barrabar o Educarmi. Godlike, buen día.
Buenos días, tempranito hoy.
Sí, hoy es tempranito, así que bueno. Esto es un episodio muy especial porque tenemos un invitado de lujo desde UK, así que bueno, este episodio va a ser en inglés, después nosotros vamos a ir poniendo, digamos, los subtítulos, así que bueno, ahora vamos a, si me permiten, a proceder al inglés, así que bueno. Hello Max, how are you?
Hi, Marino. I'm very good, thank you. Yeah, I'm doing great. How about you?
Okay, so first of all, tell us a little bit more about you, who you are, just a quick introduction, where you are based, where you're from, what do you do, what is your job, that kind of thing, so people can know you.
Cool. So I'm based in the United Kingdom, and I'm working for IBM in Hersley. And so what I do is I'm a developer experience engineer for IBM MQ, which is a message queuing product. So I'm quite interested in systems and how you join those parts of the system together, and that's really what I'm interested in my job, really.
Awesome. So what we're going to do today is just the very basics, MQ 101. So maybe what Max is going to do, just run a couple of very quick demos for us and show us just the very, very basics of MQ 101. So that will be pretty good. And then, of course, I am not qualified enough. So here we have Godlike with us, who is going to be kind of like our sort of technical experts, so experts who he can validate all this for you. So yeah, pretty much, Max, you can take it away. Is that okay?
So with MQ and with messaging queues, basically it really comes from the fact that you want applications in your software and in your solution to be able to talk to each other, and you don't want them to be blocking. You want them to work on non-blocking principles, and you want them to be asynchronous. So you want applications to be able to work separately but talk when they need to communicate, but not stop each other from actually doing units of work. And so what we're quite interested in MQ is making that possible. So what we want to do is basically make sure that when you send a message in your infrastructure, wherever you are, like if you've got lots of applications joined together that are all doing different things, you've got to make sure that wherever you send a message, you can make something happen in any of your other applications. And really, that's what MQ does really well, is that it makes stuff happen.
Awesome. So feel free to share your screen now and show us, about, because I know there's also this protocol called Mqtt, which is an open source protocol, right? So that's kind of different.
One of the protocols that you can use with IBM MQ, but there's a few others. So there's a few open source ones, but it's sort of slightly different. So MQ works in a certain way by putting messages onto queues. And then taking those messages from those queues, whereas MQTT works where you publish to a broker and then you subscribe to a topic on that broker. So basically, that way you can publish information, and then anyone who's interested can talk to the broker and say, "Hey, I have my authentication, and I can talk to this broker, and I can get information about that topic." So, for example, if I want to get I have an app on my phone that lets me book a flight, and I'm in the airport and I'm waiting for my flight, and I want to make sure that it's up to date, and that when I refresh, I can see, or when my phone refreshes, it's able to tell me the current time that my flight is going to be. So if it's been delayed, I'm going to know about it. And what MQTT can do there is publish out to all of the devices. So it can publish to your phone and say, "Hey, here's a push notification now. Your flight has been delayed by half an hour." So it's quite useful like that. But they actually, with MQ, you can actually do publish subscribe as well, just all with queues. And so it's actually they kind of work very complementarily now, I would say, except with MQTT, it's usually for very low power devices, so really tiny processors. So the Raspberry Pi, lots of people will use MQTT, and little tiny processors, stuff like that. So it's kind of, you see it used a lot for like making projects where you're just hacking stuff and you want to get something working, and you want to home IoT projects, for example, stuff like that. So you do see MQTT in that space as well. What I kind of want to show you, first of all, is I'll tell you there's two ways to kind of do messaging in a message queuing way. There's point-to-point messaging, which looks like this. And what this is basically where we have a message producer, so something that wants to communicate and make something happen. And you have a consumer of that message, so another application. So, for example, it could be, this application says update this database, and this application is the database app that needs to do that update. And so what you do to communicate is you put a message onto a queue, and then when this database application is ready, it will take that information and it will take it from the queue and then process that information. So that's kind of point to point. And the advantage here is that you can scale this up. So if you have more applications connected, you can have more producers and consumers, and they all can talk through the middle of this MQ thing, this server, basically, what we would call a queue manager. And that's kind of one way of working. The other way is publish subscribe. And I'm going to show you demo examples of both of these in just a second. I just want us to be clear about what we're going to see. With publish subscribe, what we have is a message producer that wants to talk to multiple consumers. And what they would do is subscribe to a topic here. So, for example, this is flights for the airport near where I live. I might subscribe to that on my phone. And then when the producer, which is the company that organizes this, the airline or the airport, they have an update, they will publish to that topic, and that will come out to all of the subscribers. And so what I want to do is just show you a couple of things about how this kind of works in practice, if that's okay.
Okay, yeah, sure.
What I've got here is actually, these are all our open source samples that we've got. They're all actually GitHub. So if you want to have a look at these, I could give you guys a link for this. But basically, we've got some samples to do MQ, message queuing in these different languages. So you can see there's Python, Node.js, Java, these kind of things. These are our Java samples that I've got open right now. Okay. But basically, it's sample code for all these different patterns, basically. So it's all the different ways you can use MQ. We've got examples for those, basically. And you can just take those and use them in your own code. And we kind of encourage you to do that because we want people to use the open source stuff. So, but basically, what we've got here is we've got some Java code, and it's talking to an MQ server. So this is basically a messaging server, which is hosted on my machine in Docker right now. But we can talk to this, and we can actually see what it looks like. So I've got this is what this server looks like. I've got a UI for it, and we can see we've got these queues on it, for example. And we can see here that there's a queue, dev queue 1, and I just put some messages on there just earlier, and we can see they were put on. And what I can do is I can get those messages. So I could do that if I do this, for example. And what basically is happening is that this application is going to the broker, and it's saying, hey, have you got any messages on the queue? And then it's actually going and getting those messages. So we can see here it's received 3 messages here, 1, 2, 3. And what's actually happened there is we can see if we refresh this, that these applications, these messages have been taken from that. And so what this basically kind of means is that what you basically do is you write code to say, send these messages or this information to an endpoint, which is hosted on a broker. And then that information can then be got by other applications too.
Nice. So what happens if no one's listening? No one is subscribed to the queue? What happens if somebody publishes, say, end messages, or any number of messages, but no one is on the other side? What does the protocol or the server do?
So for MQ, our default is when we're putting messages onto a queue, it's actually slightly different to publishing to a topic. So we actually have two, I can show you actually. We have inside of our queue manager, our server here, we've got the queues, but we've also got our topics and subscriptions. So we can see if we publish to a topic, it will go into here, into this topic string. And if we publish to a queue, it will go to these queues. Right now, what the kind of difference is that with point-to-point stuff where I put to a queue, that message will stay on the queue. It's not going to be immediately wiped. It will stay on the queue, and it will persist there if you want it to, until an application comes and gets it. So let's actually show that. So if I just put a couple of messages on here, for example, let's put 3 messages on here. So I'm just running my Java code that I just compiled earlier. But if I'm running this, it's going to put 3 messages onto the queue. And if I go here, I'll see them. There's a bit of a time delay because we slowed it down on the code just so people can see them being sent. But if I refresh here, I should be able to see there's now 3 messages that have just been put again onto this queue. So that's just been put now, 12:25, which is the time where I am right now. So these, there's no application listening for these at all. And these will stay there until either either they're written to disk if the queue manager dies, if you want, or until we just restart. So those will stick around as long as the broker's around, and possibly afterwards. But if I want to get those, all I need to do is just connect up again and say, hey, get me those messages, and it will get the messages from that queue. So that way you don't need to worry. You'll see now it's just gotten all 3 of those messages right here. This is a message 2, 3 here. So you've got those basically. And this way you can send, this is the really powerful thing, because you can send a message to a queue and then leave it. And then you know that when the application needs that information and it's ready to actually receive that, it will get that information. So the message is stored on that queue until it's ready to be consumed.
Right, nice. In this case, I think you're sending a message and they're going away. Is that because this is a one consumer queue?
The usual way in Mqtt it works with putting messages onto a queue is when it's been consumed by one application, it is then removed from the queue. You can change that. You can also stream. Actually, there are these things called streaming queues where you can actually write all of that to another queue. So you have that stream log of all of the data, which is really like a cool kind of thing that makes it work in an eventing way. But the more typical use case that we see is more that people are doing it because it's, for example, hey, I want this thing to happen. Like it might be, an example where you really don't want that data to stay around. It might be, hey, this is some personal information or something. And so in that case, you want to put a message to the queue and know that only one application, the application that you need, can get that information off, to be a bit more secure there as well.
Nice. And of course, we're talking about, what the protocol supports, encryption and authentication and things like that. So no one who's unauthorized can read that, right?
Yeah, so there's quite a few ways to do that, actually. So there's username password authentication, but you can also do TLS wire level encryption as well. So basically, when you communicate with this server, with the broker, you're communicating along something called a message channel, and you can encrypt that channel with TLS. So you do a handshake where you encrypt, and you can choose like all the different cipher specs you want to use. I think we now have TLS 1.3 as well, so it's staying current. But basically, it means that you can do a handshake where you're authenticating either anonymously or mutually. So you can basically have the queue manager certificates on your application, and that way you can make sure that you trust the queue manager and that they trust you.
Nice. I think you mentioned that you had some examples in different languages. Is there a Python one by any chance?
So I'll show you. I'll give you a link to it, which maybe I could do at the end. But with this stuff here, there's a repo full of these samples, and you can take them, and we encourage you to have a play with them. But hopefully you can see here that it's just a GitHub repo, and we've got all of these different languages, including Python. So please do go there if you want to have a look. For now, I'll show you because I've already forked that repo, and I've already cloned it to my machine. So basically, Python samples here. We do have things that will let you do putting and getting, which are these basic operations. And we're using an open source client. So we're using something called PyMQI, which is an open source client implementation that lets you talk to this. So that's kind of what we do with putting and getting. But we also do request response and pub subscribe. So
that's interesting because if I'm not mistaken, correct me if I'm wrong, but message queue protocols like Mqtt and maybe AMQP, they're supposed to be kind of asynchronic, right? Asynchronous. Because it's communication that you send the message and you forget about it. It's going to be delivered either way. But with recursive response, we're talking about there's a certain level of synchronicity.
With request response, it's kind of like you want to send a message to somewhere and make something happen, but then you also want a confirmation back, or you want something back to you to say that has happened. So for example, there's a little demo that I made with a Raspberry Pi, and I made this with basically, I hooked up lights to the GPIO pins of a Raspberry Pi, and we played this little game where you had to memorize like the colors, and this was just for a demo for schools that we did. But basically, what we did there was we used request response messaging. So we had a Python application which was running on that Raspberry Pi that would talk to an MQ server on my laptop. And so it would talk to that using request response. So it would basically, we'd kick it off. We'd set on my laptop, we'd set the pattern of lights and the difficulty of the game and so on. And then we would send that information to the Raspberry Pi. And then when the user had played the game and they'd either beaten the game or they'd lost the game, we'd send their score back as a response message. So that way we were saying, hey, for this user, what's going to happen to this user is we're going to know their score by the end. And the good thing there is that, like, if I had 10 users all playing the same game at the same time, on different devices, I would get the correct score for each user and I'd be able to rank them. Because the response ties directly to the actual like the information that you sent in the request, because you say, hey, I want a response and I want it specifically for this person here. So you can do that way as well. Actually, the cool thing is that what we do is we just build on the patterns we already have. So we actually stay asynchronous, which is really cool. Because what we do, right, is we put a message, say I send a message to my Raspberry Pi saying start the game with these parameters. And then what I'll actually say in that message as well is, reply on this queue or reply with this correlation. So this ID on the message, basically. And so what that means is that I can put a message to a queue that says start the game. And then when the Raspberry Pi is ready, it will take that information and start the game. And then when the user has played the game, it will say, I know where to reply to, and it will put the score onto another queue. And so then when my laptop is ready, it will actually take it from another queue. And so that way it's always talking through queues, and that way they never have to talk directly, so it's never blocking.
So if somebody were to, wants to start dabbling with this, what would you recommend to use in terms of broker? Well, client can be in any language from what I'm seeing here, but in terms of broker, what would you recommend?
Right now, so far, we've just talked about MQ, so message queuing. We've not actually talked so much about message queuing with Mqtt. It's actually a separate thing for MQ. I mean, there are lots of brokers. There are free ones, and there are. I actually think they're all kind of free for developers, actually, that I know about. I mean, my one, IBM MQ, we also have like a badge qualification you could do to like earn a skill badge. Where you've built some applications, and then you show that you know what you're doing, and that broker is free to use for developers. But there's loads of free ones as well. To be honest, I mean, there are other products available, and you can use things like AMQP inside of MQ, or with something like a different broker which is open source like ActiveMQ. So you've got lots of options there.
So you mentioned Mqtt, right? So what's that? How does that compare to what we've seen so far?
It is slightly different because it comes from the same place, because both of those things were developed in Hursley, where I work in my department, but they are very separate, because Mqtt is really designed for really low power, highly constrained environments. So originally Mqtt was designed because basically there was a company that had oil pipelines, and what they wanted to do was monitor the temperature of the pipes and make sure that the insulation was working, and send that information up so they could work out the temperature of the oil going through the pipes, because they needed a certain temperature so the flow rate would be good enough, basically. But they wanted to send that to a satellite link. Yeah. So they didn't know how to do it, and so basically what happened was there's a guy who works in IBM called Andy Stanford Clark, who he basically thought, you know what, I think there's a way to do this where it can work on really low power devices, and we just publish information from those, and they can go up to the satellite. But with the satellite, basically, it would cost you over the course of a year to send a message in this way. It would cost you, for every single byte that you send, it would cost you about $1 million. This was in 1999, I think they released it, and that was the number. Like, if you want to use the satellite, because it was so constrained, because it was newer technology, and it wasn't so it was a consumer application, or not like an enterprise application rather than government research, and so you had to pay a lot of money. And so basically they were like, oh dear, we need to make sure we can make the most small constrained thing that really just sends the bare minimum information up, and doesn't give any information that we don't need, right? And that was super important, because otherwise they just wouldn't have been able to actually get it working. And so they managed to make this protocol, and it's now used all over the place because it's so lightweight. You can run it on on Raspberry Pis and on tiny devices which need very little processing power. So even tiny edge sensors. So it might be now, rather than testing oil pipelines, it might be like you have it in your home IoT project where you want to know how warm is my house right now, and do I want to automatically turn on my heating or on my AC. And so that's now the kind of thing it's moved to, in that now you can use it even in your house really easily. And this is a free thing. It's it's open source. It's an open source standard, and there's loads of free brokers and there's loads of free clients you can use. And so what I've got a demo for you. I'll show you a couple of pictures of it working in action as well in a second. But what I want to do is show you. There's my tab. There we go. Is that basically here I've got a couple of really simple applications, and one of them's doing, this one here, is just basically publishing random numbers to a topic, and the topic is lucky numbers, and it will just say, hey, your lucky number is this number, basically. And then I've got a subscribing application here. And what that will do is basically for 1 minute, I start it off and it will go into a thread. So it starts a thread that listens on the topic called lucky numbers. And it will basically, if any messages come in that time, it will take those messages off and it will use those messages. And so that way we can basically send messages from one place to another.
I have a question, because you mentioned this started as, in environments that were really constrained, right? Things like this amount of power, this amount of connectivity available. Does this scale well? So let's say I want to use this for a huge project. Is it suitable, or should I be looking somewhere else for this?
It does work in that it will work across networks, and it works all over the place, and people do use this stuff all over the world and like to send stuff from all around the world. But basically, if I run this thing, I've got a broker here, and this is a free open source broker called Mqtt, which I know, Manuel, you've had some look at this one as well, and you've played with it a little bit. And basically, it's just it's really, really lightweight and easy to set up, and you just run it straight away. And once you've run it, you can send stuff to it and to topics, and it will create those topics for you, and it'll work dynamically. So if I let's see. So if I subscribe here, I'm just running my subscription application here. And what that's going to do is just look for messages. And if I publish some messages here by running my publish application, we can see that it's publishing these messages, and it's immediately getting them as well. So it's going to the topic, and then this subscriber is getting those messages immediately. So that way we're able to send messages just really, really quickly. And the footprint of these messages is tiny. So it's literally like these messages are, just as small as possible, basically. So that's the really powerful thing, is that they do just go over as bytes, and then they're converted back at the other end, so that, if you have like a home project where you're making and building, it's just a really easy way to get it to work, where you really don't need much power or much bandwidth or much network traffic to actually do that.
Right. And the other question was about, because I'm still thinking about sending satellite data in the 90s, right? Right now, we'll just put a cheap cell tower somewhere and problem solve. So how tolerant is it to connectivity problems? Things like we lost in packets, things arrive out of order, retransmissions, that sort of thing.
It depends on your project. So it depends, for example, do you care, how much do you care about your messages? Like persisting is a good question to ask yourself. So if you say, it's just, maybe I've got, for example, I've seen a real use case of this would be if you have a robot, and you've got maybe you've got 100 different sensors and actuators on your robot that you need to inform of things. Maybe say it's a hand that waves at you when you come into the room, so it's got a camera and it sees movement, and it's able to track that, and it's able to then control a series of motors to open the hand and wave at you, for example. That would be a use case that the kind of thing that we see, and that kind of thing, that would be pretty useful, because you might have 100 different things you need to talk to or instruct, but really you've got one source of data that needs to then drive many things to happen. But the thing is that if one message doesn't go in, if one tracking message doesn't get through, that doesn't matter, because it'll send the next one. And so it's like you don't have to worry too much about failures like that. But if there's an environment where you do care about failures, then you're going to have to think about possibly, do I want to use this? Because at that point, it might be slightly less reliable to use. And actually, that case that you mentioned, Manuel, is like the kind of case where you might use MQ. Because if you have a big system and you really need all these messages to go through, that's the kind of case where MQ is the way to go, or where message queuing is the right thing for you, rather than maybe just publish subscribe. So you've got all of these different ways to do it, but really it's kind of depends more about what your system is exactly, I think.
Right.
So with MQTT, because you're just publishing to a topic, you might lose some messages. Sometimes there are ways to minimize that, to change how the broker actually works internally, but that's then increasing that bandwidth, right? But with it's the kind of thing with that now, yeah, you're right, in that kind of data you might use MQTT, but there's also use cases for message queuing or streaming, because in that case you can choose for message queuing, which is what I know, you can set the persistence level. So that's pretty useful, because it means that basically you can say, like, either if something goes wrong and I want to recover this message, for example, so you can do that. But you can also set typically message queues are first in, first out. You can change that as well, but basically it means that you can get them in the right order. But they will also usually have timestamps. By default, they would do. So you can sort of order them that way, but you wouldn't. Usually you'd set that as property of your application. With MQTT, that's less functional. So typically what people would use MQTT for is things where it doesn't matter if there's a couple of things that go wrong. So with back in the 90s, it wouldn't be too bad if your data got a bit scrambled for if a couple of your messages every day didn't quite go through properly. You'd still have enough information to do the job. With all of this stuff, the technology's come a long way in 20 years, and so you've got so many options now in ways to do it. So there's not just queues. You can use streams, and you can publish to topics, and they're all very different, but they all kind of work together quite well now. So I think now that that it's become really, I guess, the case that we know that all of our applications now are going to be over a network. It's all going to be distributed stuff, and that's just the way computing kind of is. We always talk over networks and stuff, and so we always have to be tolerant to these faults and failures. And it's just how tolerant do you want to be? Like with MQ, with IBM MQ, you can say, look, this is not going to get missed. We are going to make sure this message goes through. Which is why you might see that used in a hospital to get patients' data, because you don't want someone to miss data like that, and you don't want that to go amiss. But with other things like I've got my home automation project, and I'm just seeing what temperature it is in my house, and I'm going to turn on my heating. If you miss one message, it'll turn on your heating in another 2 minutes anyway. So it's kind of all good.
Can you show us any more cool project that you built in this?
Actually, I'll show you. So it's this one here. So basically, I've just got loads of pictures up. And we did make a few weird demos in my team, because we quite like making stuff with MQ, because it is quite fun to play with. And it basically we got a build of MQ that works on Raspberry Pi, which usually it was just on like a server like it would run on Windows or Linux. But now we have a build for Pi, and so we thought, well, what can we make that shows what we can do with this thing, and what test the limits of this technology. And so the picture on the the right is just the MQ we actually got. That was the first time we got it running on the Raspberry Pi, and we thought we'd take a photo. But the one on the left here, what we've got two Raspberry Pi Zeros that you can see on the right hand side of the image. Both of those have MQ servers on. And what we're doing is we've got a little Arduino here, which is controlling some LEDs. But what this basically does is that there's a camera routed to a Raspberry Pi. This tower here of Pis, there's actually, you see the ribbon here, but this is the camera. So what it does is it takes a photo of you, and then it would send the photo through a system to another computer in different chunks. So it would cut your face up into chunks, and then it would reassemble them on the other side. And it would do that just to say, like, hey, look, we can send something from one place to the other place. But then what we did was you can see here, there's a little wire and a button here, and you could press that button. And what it would do is it would kill the MQ server. It would stop it. It would shut it down immediately. It would force it to quit. And so if you were sending messages across when that happened, then what we'd wonder is what happens, and can we make it still save all the messages and put it back together? And so what we did was we have this way of working with multi-instance queue managers. So what you do is you have a standby queue manager that looks at your other one and goes, okay, are you still good? Are you still good? Are you still good? And then if it stops, it goes, oh, you have a problem. Then it'll say, okay, I'm going to now be that broker. I'm going to take up that role. And so basically that means that when you press the button, it will kill the queue manager, and the other one will send all of your messages through it. So that way, if you want to be super, so I know one you sort of talked about fault tolerance. This is a way of becoming even more fault tolerant. And actually now there's a way of doing it where you actually have clusters of 3 of these things all working together to agree on all the messages that have been sent. And so that way they that basically if something goes wrong with one or even 2 of them, you can still sort of get messages through. And so that's quite powerful. But on this level, we just wanted to let people know, like, hey, you can do weird stuff with messaging, but if you interrupt the messaging, you can still get all the messages back in the right order. The other thing that we did make as part of that sort of Raspberry Pi stuff is this weird project here with the flashing lights. So essentially it was a plugin for messaging and message queuing inside of Scratch. So this is written in JavaScript, and what you can do there is talk from your web browser to your other devices. So in this one, what happened was my web browser was talking to the broker on my laptop, the queue manager on my laptop, and that was talking over a network to this box of lights here. And basically that was running a Raspberry Pi. And so we were talking from the web to my laptop to the Raspberry Pi, and we were doing request response messaging that we talked about earlier, but we were doing that to play a little game so that people could come along and see, oh, so what's this thing all about? And we could show them this game, and we could let them play it and then explain to them as a teaching tool, like, hey, you know what's happening here is that all of these messages are going onto queues, and it all works like this. So we were using from the browser to the server, we were using REST. And then from the server on my laptop to the Raspberry Pi, we're actually using the Python client for MQ. So we're using PyMQI, which is that open source client, and we were sending messages with requests there, and we're doing request response messaging through that entire system. And so it was just a nice way of showing people hey, here's some weird stuff you can do.
So Max, this has been, we can stay talking all morning about this. Just some closing stuff. If anyone wants to start playing with this, what would you recommend? We're going, of course, to leave all these links in the YouTube description, but what would you recommend to start with?
So there's a few things. It depends what you're most interested in right now, honestly. If you're interested in IBM MQ, we do have a badge course that you can do. So with the badge, what this basically does is it just lets you go through some steps to build an MQ application and understand what's happened and set up an MQ instance yourself. So with that way, that's quite useful. Actually, I would add there is also a YouTube series on how to use IBM MQ. There's a whole playlist of videos about messaging and about how it all works. There's also, if you're interested in using MQ on a Raspberry Pi, there is also a link for that as well. So you can use MQ on a Pi. With MQTT, there's loads of brokers, because MQTT is a standard, so it tells you how these things should be encoded, but that's implemented by a load of brokers basically. And so the one that I find is easiest to use for me is Mqtt, which you can find, it's part of the Eclipse Foundation. It's open source, you can use that whenever, and there's test servers and everything up there, so there is loads of good stuff there. There's also I was using, in the demo I showed you, I was using Python, and I was using this Paho client, so Paho MQTT client, which is you actually have multiple languages there, and I've played with the Golang one as well, but the Python one is available here as well. And so if you were interested in Raspberry Pi and getting going on Python, that's the one I'd recommend for MQTT. And there's loads of information online about that, because it's it's been around a long time, and it's kind of like the standard for IoT. So there's loads of information that you can find about this as well.
Awesome. All right, Max, thank you so much for your time and for joining us. I hope we can do this more often to get more international guests for our Latin America audience. Thank you, Max, and thanks for joining us.